Hey guys, welcome to Module 1, Chapter 8 Presentation Redo. I am Willa Vaughn.
I'm Anna Jones.
I am Chris Crow at your service.
Okay.
I am not the smartest person, and I have a question for Miss Willa Vaughn.
Yes, sir.
Willa, I need you to explain to me, how do we know which graph to use for the scenarios that we're given? Like, how do we know which graph is appropriate for every scenario, every different scenario?
All right, that's a great question. So I'm going to start out with a graph that shows the scenario with how much gas is in a tank with the distance in miles. So first thing you're going to do is you're going to label your X and your Y axis. So you can see, let me get a pointer up. So you can see down here, this is going to be our x-axis, and that's going to be the distance in miles, and that's going to be how far we move. And then here is going to be our y-axis, and that's going to be how much gallons of gas we're going to use while we go the distance we're going. And there's our little star. So kind of how you're going to do this is you'll see the animation moving. So as you go down, you rise up in the distance, your gas is going to go down, obviously, because you're going to be using your gas as your distance gets greater. And then you see our gallons of gas go up, but our distance stay the same because we are adding gas into our gas tank and not actually moving. And then there's a sharp decline because we're using that gas up with our distance.
Okay, so it's largely kind of just critical thinking being applied to a graph.
Yeah, it's very kind of imaginative because you've just got to kind of think if you're getting a greater distance, you're going to lose gas. And so you're going to kind of have
Right.
a choppy kind of graph.
Yeah, that makes
Okay.
a lot of sense.
Yeah. So
All right.
Anna, can you show us an elevator graph? What that would look like?
Yes, ma'am. Here we see a graph of an elevator where the x-axis is the time, or I'm sorry, the x-axis is the elevator floors, and the y-axis is going to be the time, or the elevator height. Where did I find some? So as the elevator goes up, it goes up very quickly, and then it stops on each floor, and you can see the stair steps where it stops on each floor, and then it goes up very quickly and stops, up and stops, up and stops until it gets to the height of the building.
All right. Yeah, it does look like a staircase, doesn't it?
It's very structured looking, much like an elevator.
Yeah, there you go.
Okay, I think I'm starting to really understand how graphs can be visualized with these different scenarios. Why don't I try the next one?
All right.
So here we have the graph to represent a ball being dropped from the top of a table and watching it bounce away. So here we see a squiggle, and it makes perfect sense because when a ball is dropped from the table, obviously when it bounces, it's going to reach its highest point, and then every subsequent bounce is going to decrease in height as the distance from the table increases, as the ball gets further away. So obviously our x-axis is going to represent the distance from the table the ball bounces, and then the height is represented by the y-axis, and it will decrease as the distance increases, right?
Yeah, that's exactly right. You're finally getting it.
Yeah.
Why don't we do one more example?
All right, I'll take that one if you don't mind.
Not at all.
Oh, I have an animation. Oops. All
Oh,
right,
that pesky ball.
So my graph I'm going to be doing is the shadow of a flagpole. So we're going to start out with our x-axis being the shadow length and our y-axis being the time of day. So as you can kind of see, we have the shadow starts out down here as nothing because the flagpole isn't going to have a shadow. And then as the sun rises and the time of day gets greater, the shadow length is going to rise as well because the shadow is going to be much bigger than the actual flagpole. So because the flagpole is going to be closer to the actual source of light. So you can see through the day, that animation, the sun is rising, so the shadow length is going to rise as well with it.
Okay, directly proportional.
Yeah, there you go.
All right, I think I got the hang of it now.
All right. Okay. So I'm a little shaky on this question right now. Where exactly does the g of x come from in the equation of g of x equals f of x plus 8, Anna?
So the g of x is basically the same as f of x. It's just we're putting f of x inside of g of x.
Okay. Yeah, so it's kind of like over here, the graph. Is it kind of taking those and you're going to multiply the 3 and then take the f of x answer and add 8 to it, right?
Yes, that's exactly how it goes.
Okay, that makes more sense.
Alrighty. So like the table on the left here, that's supposed to show off the different ways that the formulas interact with each other. So we see f of x equals 3x. So then the g of x, the g of f of x is basically going to be whatever f of x becomes, and then that just added to 8.
Okay.
Yep.
Yeah, that one makes a lot more sense now. Thank you.
And you can see over on our graph that adding 8 to it has made the graph jump up 8 units.
Mm-hmm. Okay.
Yeah.
Well, thank you guys. That makes a lot more sense now.
Anytime.
Glad to help.
Okay.
All right. Now, guys, I'm a little confused on this part. Can you explain to me what y2 and x2 mean in the slope formula?
I am actually quite knowledgeable on that and would love to answer it for you, Anna. So when we're looking at the slope formula, what it's largely asking is to determine the change in the y's divided by the change in the x's. So here we have our points P and Q. We have point P, which is 3, 1, and then we have point Q, which is 5, 5. And so obviously we have it grafted on our chart here. At some point we'll have our triangle pulled up after the angle has been created right there. And the slope formula is actually going to be y2 or m equals y2 minus y1 over x2 minus x1. And what the y2, the x2, the y1, the x1, what those are actually the numbers within the ordered pairs that create this angle, or at least the line in particular. So in point P, we have 3, 1. So that is actually x1 and x2, or no, sorry, that's x1 and y1. And then point Q, 5, 5, is y, oh my gosh, sorry, x2, y2. So then you take those numbers, you place them in their appropriate spots, and then what you end up doing is somewhat normal subtraction. You will subtract the numbers and then whatever you have left, so in this case it's going to be 4 over 2 after the proper subtraction, you're going to simply divide that change by itself. And then in this case, you're going to get 2 as your final answer. So 2 equals m, the slope.
All right, thank you. That makes so much more sense now.
Of
Yeah.
course.
All right. I think I'm going to try the next one and explain this one.
Go for it.
Okay, so it's going to be kind of just like how Chris said. We have our points P and Q. So right here, P is going to be 5, 8, and then Q is going to be 5, -8. But you can see we have adjoining y values, so y and -8. So we have a straight line. So when you have a straight line, a vertical line with a slope, you don't actually have a slope. You have a slope that's undefined because slope is defined as rise over run, and you don't have a run when you just have a vertical line, you just have a rise. So you can't actually, you get -16 divided by 0, and you can't divide anything by 0 that is an undefined answer. So you don't have a slope for this one because you have a straight line, a vertical line on your graph.
And nobody wants to create a black hole, so we are going to refrain from dividing by 0.
There you go.
Yeah, I was kind of wondering why that one was a straight line.
Yeah, the y values are opposite. All right, Anna, you think you got this enough that you can try and explain one of them?
I think so. So here we have point P and Q, P being -1 and -4, Q being -4 and -13. So our first step is going to be plugging in our x and y values into our formula. And we're going to get -y over -3, and that divided is going to equal 3. Because when you divide negatives, it becomes positive. So this line has a slope of 3.
All right, that's very well put.
The edumacation is obvious. Alrighty. So I have another question.
What you got?
How exactly do we find the points in the ordered pairs in order to graph a function?
Okay, that's a pretty simple answer right there. So what you have, so I'm gonna kind of assume that you mean how do you graph those points. So you can see over here we have our points already determined. We have -10, 100 right here. So what you would do is you would come over here and you would find x, which is going to be our x-axis, and you would find the, I'm actually going to start with +10. You would find +10, and then you would find the y value, and then you would go up kind of like the slope, the rise over run. You would find your x-axis, you would go up, find your y-axis, and then you would plot the point.
Okay, so it's largely kind of just, it's very similar to plotting a normal graph, except this time we're going to have, in this case, curves instead of an actual angle to create.
Yeah, you're going to have a parabola.
That's what it's called.
Yes, sir.
And the way the parabolas are set up right now, that's how it's supposed to look when you're doing it correctly, right? Slight vertical changes between them.
Yeah, so you can see over here, in our table, they're just similar enough that they're going to be just a little bit off of each other.
Right.
Okay. Okay.
And the vertical change is caused by the +7 or the -7 working outside of the x squared.
Yeah, exactly.
Okay. I think I've now been educated on how to do this. Thank you very much for the assistance, Willa.
Of course, anytime. Okay, so I actually have a question as well. So we know how to plot these points now, but what does the x actually stand for in the equation of the line?
I'm glad you asked, Willa. The x in the equation of a line is the value that we're going to be adding into our line. So our equation for a line is y equals mx plus c. So m is going to be our slope, x is our variable, and b is our y-intercept.
Okay, so it's kind of like a number that you haven't plugged in there yet.
Right.
Okay, that makes a lot more sense.
And here on this,
if I may interject, the function we have, or the function table, I should say, we have on the left side, that's not the required set of numbers to use, but that's the most likely appropriate one to use, like -10 to +10, just because it's a decently ranged set of numbers so that you can get the best and most accurate depiction on the graph.
Okay, so it's kind of because you have a wide variety of numbers that way, right?
right.
Yes, that's probably the best way to go about doing it, in my opinion. Just because
Okay.
you have such a wide variety to choose from, your results, as you see on the graph, are going to be a lot more defined and easier to spot.
Right.
Okay. Yeah, that makes sense.
And on this graph, we're actually showing a perpendicular line.
That graph, sorry.
Yes, yeah.
Technology.
So on this graph, perpendicular line, and we had to find this line by using the reciprocal of the slope of the original line. So on the table, you can see here that we did that because we took the reciprocal of -3/4 and changed it to 4/3.
Oh, okay.
Okay.
Yeah, I see where it's opposite up here now.
Yeah.
So it
Okay.
really kind of is just a matter of plugging in the right numbers and then just evaluating them from there.
Yeah.
Yeah, what's that saying? Plug and chug, right?
That sounds like the most appropriate saying.
Yeah, I haven't heard that one in a while.
I've never heard.
Huh. Yeah, that's what they told us in high school, I think.
You learn
Yeah.
something new every day.
All right.
So as we see here, we have our math drawn up on the left side, and it pretty much is just the repeat of part A of question 5. We're going to take our x and y, and we're going to plug in the numbers. In this case, y minus 3 is going to equal 2/9, or x minus 0. We're simply going to plug in the numbers into their respective formulas. We're going to apply the appropriate algebra. Eventually, it will give us y equals 2/9 times +3, or not times, x. 2/9x plus 3. And then from there, it's as simple as simply plotting the different lines to give us our appropriate function. Although Anna explains it way better than I.
Okay. Yeah, it's basically what we did in the last one. We just have the math drawn out.
Yeah.
Okay.
For the students at home.
See, the lines are still perpendicular.
Yeah.
So you can tell you right.
Okay. Well, thank you guys. That's really helpful.
You're very welcome.
All right. I have a question. I'm not quite sure about this one.
Yes, ma'am. What you got?
What is the origin of a graph?
I am glad you asked that, Anna. I can answer that with ease. So the origin of a graph is actually the very center, as you can call it. It's the 0, 0 point on a graph. The very center where everything originates from, the origin. And so
That
here
makes
we
sense.
have our little yellow box that we're going to use to represent the origin. And the question we're being prompted with, we have to show and explain the equation of the line that is tangent to the circle of radius 9 at 0, -9, and whose center is at the origin. So obviously I've explained what the origin is. The radius is half of the diameter, and the diameter is from one point of the circle to the opposite point of the circle. So the radius is half of that. So of course, we're going to have our little yellow box, and we're going to take it downward to point 0, -9. And if you can see the red line at the very bottom, that is what we call the tangent, which is the point on a line where it just touches the curve of the figure. So obviously the radius is 9, and the tangent is at point 0, -9. And that's applicable to all sides, all angles, all ordered pairs of this particular circle.
All right,
Okay.
that makes a lot more sense now.
It's not the most difficult thing when it's explained in broad terms.
Yeah, I think I'm gonna take a stab at it now and do the opposite that you did, Chris, and go above. So you did the tangent line at 0, -9, but I'm going to do my
Yep.
tangent line at 0, 9. So you explained it right. I mean, it's just the one that's going to touch on the curved edge, but I'm going to do mine opposite of the one you did. So any of these, obviously it's a circle, it's going to be a curved line. So the radius is still going to be equal to 9, but it's going to be at 0.09 now instead of 0, -9.
Okay, so kind of following the opposite but equal idea.
Yeah, exactly. It's an opposite point, but it's equal to the same radius of the first one.
Okay.
Yeah, that makes sense.
Yeah.
All right, I think I've got it well enough now to where I can hop in and maybe do this one.
All right. Let's see.
So it says compare the line in part B to the line in part A. So the difference between these two lines is that they're on opposite sides of the circle.
Mhm.
They have the same radius, but their points are different at which they touch the curve of the circle. And it's
Yeah,
important
exactly.
to note that the tangent just touches the curve. It doesn't go through the curve.
That's a really good point. Yeah.
And if we were to have two tangents on points -9, 0, and 9, 0, they would be the exact same way, right? They would be just touching the curve, completely opposite of each other.
Yeah, they'd be like parallel lines.
Yes,
Yeah,
that is the word I was looking for.
that's a good way of putting it.
All right, that's much more thoroughly explained now. Alrighty.
Right.
Yeah, I think we're ready to move forward, guys. This lesson, I'm a lot more knowledgeable now that we've done this. How about you guys?
Oh yes, I can feel the big brain time swelling.
Of course.
Well, we thank you guys so very much for joining us on tonight's redone lesson, revamped, renewed. We hope that you will join us for our next and upcoming Team Teach, which will be our Module 2, Chapter 9. Until then, thank you guys for listening. You all rock, and as always, this is Chris Crow signing off.
Willa Vaughn, bye guys.
It's Anna Jones. Bye.